Hi everyone, we're going to go through the introductory session for our first SAC in this video. So basically covering things like how to find the equation of a function given a graph and how to kind of look at reflections or transformations for graphs. And also it's a heavy use of using the calculator. So in your SAC, it's just not about doing everything by hand, but using your calculator to help you. So you'll notice on this first page, we've got 4 graphs and they all kind of look like an X of some sort. So we've got a linear graph to start off with, then we've got a parabola, then we've got a log function, and then a sine function or sine graph. So what we're going to do in this video is look at how to get the equation of these graphs given the information that's given, but also if you want to draw a graph, okay, because you can draw any graph however you like, but then how do you get the equation of that? So for example, you might want a certain turning point, you might want it to go through a certain x-intercept, to have a certain x-intercept or a y-intercept, things like that. So how to draw your graph, but not just that, how to get the equation of that graph. Then on the second page, we're going to look at just a cubic and how to get the equation of a cubic. What we're doing in this second part is very similar to 10G, so please make sure that you're familiar with the questions in 10G. There are videos for every question in 10G as well, so if you haven't done that already, you can watch that. And then we're going to look at like the gradient function. So these blank axes, we're going to do some sketching later on. All right, so let's start. So I'll be sharing these notes as well. So if you want, you can listen and take the notes. You know, obviously you can pause because it's a video, or rewind or fast forward, whatever you like, doesn't bother me. And I'll give you a copy of these notes. It's probably best that you just don't copy the notes and not listen to the video, simply because I'm going to go through not only how to do things by hand, but how to do things on your calculator, and things that I know I haven't shown you before unless you were there for the introductory lesson. You may have been shown last year, okay, but it's going to be very helpful going into your SAC, being able to do things a lot quicker on your calculator. All right, so let's get started. So the first graph, we've got f of x equals 2x, and we've got a domain here. So make sure whatever function you have, you always write the domain. Okay, and you can use whatever notation you like. I've just done this one here. Yeah, so you're familiar with the different types of notation for the domain. So use whichever one you're more comfortable with. Just make sure whatever one you use, you actually use it correctly. All right, so what is being sketched here is that this line here is f of x equals 2x from 0 to 5. Now we do have some transformation. So you can see that this green line, or that I'm highlighting now in pink just to confuse you, has been reflected in the y-axis. And we've got a reflection here. So we're looking at the original blue line. It's been reflected in the x and the y-axis. And then we also have this line here, which is just reflected in the x-axis. All right, so let's have a look at, well, how do I actually get the equation of a straight line? So you're familiar with y equals mx plus c, or hopefully you are. So remember that m equals your gradient, and c is your y-intercept. So for this blue line, I can say, well, I want it to go through the point 0, 0, and I want it to have the endpoint here at 5, 10. All right, so I would use those 2 points to find the value of m and to find the value of c. So that's how we get y equals 2x, or using function notation, f of x equals 2x. Now the reason I'm using function notation is just to show the different transformations. So for your pink line, so actually the blue line we're starting off with f of x equals 2x, so it's this line here. This is f of x. Then your pink line is a reflection along the y-axis. So basically anything that was a positive x is now a negative x, but your y values stay the same. So that just means it's going to become negative 2x. And you should be familiar with linear graphs and know, okay, well that pink line, clearly a negative gradient. You can even work it out if you want to, and it's a linear equation. So that's f of negative x. Now your domain, because the blue line has been reflected, your domain has also changed. So now it's going from -5 to 0. Okay, so as I said before, always make sure you write your domains. All right, we had this domain written before, but we'll write it again. Okay, let's do the green one. So the green line has been reflected along the x-axis. So that's basically anything that was positive y now becomes negative. And we also know that's basically just an extension of that pink line. So it's still the same equation. All right, but your domain, because I restricted it, first of all, means that, you know, the reflection for the pink line only goes from -5 to 0. It doesn't keep going along that green because I restricted the domain. Okay, so this is negative f of x. And then the yellow line, we've got two reflections. We've got a reflection in the x-axis and a reflection in the y-axis. Should put a negative in there. So basically we're going to have negative 2x, and that's how we end up with positive 2x. But your domain is now from -5 to 0, okay, because it's been reflected. Now, let's write that on here, negative f, negative x. All right, so I'm just going to write the transformations very quickly. So reflected along y-axis, reflected along x-axis, and then the last one is reflected along the x-axis and y-axis, and the order doesn't matter. Okay, you still get to the same point. Now on your calculator, and I'm going to show you this a few times, just move over here. So if we've got a complicated function, and you're going to obviously get more complicated ones than 2x, it's always a good idea to say to your calculator, all right, Casio, let's store this in my calculator. All right, so I don't have to keep writing it, or I don't have to copy and paste it every time, which can get very annoying, especially if you've got a long one and it goes off the screen. Okay, so in your keyboard, go to define. So basically we're saying, all right, Casio, let's let f of x equal 2x. Press enter and it says done. No worries, done that for you. So you can do your reflections. So we can say, all right, let's do a reflection in the y-axis, -2x. Let's do a reflection in the x-axis. Oops, I always do that. Got to use, because I'm using my keyboard, but you got to use this button down here next to the 0. Negative f of x. Okay, and then if we had negative f of negative x, we should end up with 2x. Okay, so, and you can do anything with your function. So if you wanted to substitute in a value, so let's say you wanted to know what y equals when x is equal to 5, it's equal to 10. You can also take the derivative. So you can go to calculation, differentiation, and your expression, f of x, and it'll do the derivative for you. Okay, so obviously this one here is very easy, probably easier to do by hand than type things on the calculator, but you can do that with any function. All right, you can also graph it. So let's just get rid of what I've had in here from before. So you can graph f of x. All right, and it'll graph it for you. You can restrict your domain. So given that, and let's just go to keyboard. What are we going from? 0 x to 5, and it's restricted it for you. And if you like, you can then do the transformations there as well. and I haven't restricted. Now, I could restrict it, sorry, I should say, when I defined it, but I restricted it here. All right, so I didn't restrict it when I defined it, hence why it reflected the whole function. Okay, so if I only wanted part like I did on my sheet, then on my main screen, when I do my define back up here, you would need to restrict your domain. Okay, so just a heads up with that. All right, let's move on because I don't want this video to go on for too long. All right, the next function is a parabola. So basically in your SAC, you've got to demonstrate what you know. So let's say you had to do something that was the shape of an X. Clearly linear, a lot easier. And you could have done negative 2x and 2x and restricted the domain from negative 5 to 5. Okay, so you get the same thing. I was just showing you how to do reflections or transformations on your calculator. And I've done the same here. So we've done a bunch of reflections. So I don't know whether I made this point, but on your SAC, if you demonstrate your understanding, so if you had to do a shape that was an X, basically you're going to impress me a bit more if you did a log graph or a sine graph than what you would if you did a linear graph. Okay, so it's basically saying, well, all right, you want this type of shape. How can you make that shape with your knowledge of functions? Okay, so if I wanted an X, there's an X with a linear, but you can see as we progress, we're getting a little bit more fancier. Okay, so let's go back to the parabola. So this parabola, remember we're restricting our domain. So at this point, it doesn't really look like a parabola. So if we're looking at this blue graph, let me just, all right, so oops, this blue part here, that's basically half a parabola. All right, it did keep going, but I only wanted it to, so all these graphs you'll notice end at the point 5, 10. Okay, so it kept going, but I only wanted it to go to this point here, 5, 10, which is our turning point. Okay, so if you wanted to make that sort of shape, obviously you take into consideration the turning point. All right, so your turning point is at 5, 10. And another point on that graph, I can see it goes through the origin. So it's not a turning point at the origin, it's just a point on the line. Now, when you're when you're finding the equation of a parabola, obviously you can do it in expanded form, factorized form, or turning point form. Now, I love turning point form because first of all, you can see the transformations, but also you can see the turning point. So your turning point form is ax minus h squared plus k. So h and k are the coordinates of your turning point. So for this one, h is 5 and k is 10. So then you just say, well, I need to work out my value of a, okay? Because it's just not a matter of putting in 5 and 10 because you could have any sort of turning point. Sorry, I shouldn't say that. You've got one turning point. You can have any sort of graph that has a turning point at 5, 10. We want one that goes through the point 0, 0. Okay, so what I mean by that, let's just have a quick look on Desmos. Oops, didn't want that, sorry. Oops. I was like, where did it go? All right, so we can see there's a parabola with a turning point of 5, 10, but clearly it's not the parabola we want. So that's why we need to find a different value of a. So on Desmos, and I'll show you in a second how to do this on your calculator, you can actually change, see how it's changing? All right, so you can see there, oh, going through the point 0, 0. All right, but you can do this also on your calculator. All right, so getting the value of a. So we need to, oh, I'll keep in pink. Getting the value of a, you just need to substitute a point in the line. Now don't substitute in 5, 10 because it's already in there. All right, so we're going to put that in a second. We're going to substitute in the point 0, 0. So h is 5 and k is 10. Excuse me. So when we solve for a, it's going to negative 10 on that side, and then negative 5 squared is 25a. So a equals negative 10 on 25, which is negative 2 on 5. Now you could use solve on your calculator, but again, you need to demonstrate how much you know. So if you're just doing a bunch of stuff on the calculator, obviously you'll get points for doing that. Okay, so you're getting points for using your calculator, but if you can't demonstrate your understanding, then you'd lose points. You don't get points elsewhere. So please make sure you're showing your knowledge of how to do things by hand. All right, sorry. All right, just glitched, sorry, had to restart. It's funny, I think I did it in the same spot when I was doing it in class as well. Okay, so what we've got with our parabolas, all right, so there's the parabola we just had. Okay, so that's this equation here. All right, and then it's from 0 to 5, okay? And then you've got a bunch of reflections. So again, if you can't do those reflections by hand, just do it in your calculator. So on your calculator, you can just go back to define. You can use F again. You can see G is already there. Don't use that I, okay, because it is not what you might think it is. All right, so I would just keep using F unless you were working with more than one function. If you wanted to, you could also get your letters from here. All right, so don't do var, variable, just do the letters from A, B, C. All right, so let's go back. So for this one, let's use G. All right, so let's let G of X equal, and we've got a fraction up here, so negative 2 on 5, X minus 5 squared plus 10. Now this time, let's restrict to the domain. So given that 0, X, 5. All right, so I've restricted the domain now. Now when you're doing your reflections, remember you can just do that. So it's going to find, what am I talking? Your function, okay? So that one has been reflected in the y-axis. So you can do the reflected in the x-axis, reflected in the x and the y-axis. You can also do other reflections. So if you wanted to translate it up, obviously go plus 5, it shifted it up 5. If you wanted to go, say, to the left 2, all right, you just do x minus 2, and you'll notice that changed to 7. All right, oh, sorry, I meant to the right 2, I said to the left. To the left, to the left. Okay, let's graph that. Sorry, getting a bit distracted. Okay, so this time, because we restricted the domain in our function when we defined it, I don't have to do it here. So just putting in G of X, and there it is. All right, so you can see it stops, and I could then graph G of negative X. Ticket. All right, so there you go. If you wanted to do the transformation, so X minus 2. All right, so you can see it's shifted along to the right too. Whatever. All right, so it's a way of graphing your transformations. Just trying to think, I'm trying to think of what that might end up looking like. It's kind of like fireworks, isn't it? You might want to play around with the different types of transformations. And then once you've got something that suits you, you're like, okay, well, let's get the equation of that. And you can do that on the main screen. One other thing you can do, now this didn't work yesterday, but let's see if it's going to work today. Now don't want to graph them. Let's see if it's going to work. Okay, oh, it's done it in pink. Where's the graph though? I need to graph. What? Where's my graph? Oh, okay. It's all the way up. There we go. It's coming back down now. So what I've got here is a slider. So I can say, well, I want to move that, but I'm not really sure what I want to look at. I want to move it up and down, okay, because I did plus D, and you can put that D anywhere. But you can see your graph is moving up and down. So you could use that also instead of typing in different numbers. All right, you can play around with that way. You could also probably put one in here. Let's just see if I could do plus A as well as a second one. So this time, you know, you're moving it to the left or to the right. Yeah, so you can put in any variable in there and then it'll add a slider. Just trying to think what. Okay, if you wanted to edit your sliders, that's what I was going to do. Just click on the little, what do we call that? A hamburger menu settings. What's autoplay? I think autoplay might just do it for you. There we go. Okay. Anyway, how do I stop you? Stop. Oh, it's annoying. There we go. Stopped. Settings. Okay, so you can see you got slider 1, and then if you wanted to change slider 2, you can. Now, it's only going up by 1. You can change that to, 0.1 if you wanted to. Okay, so for this one, because our value of A was -2/5, okay, if I had a slider, I probably wouldn't see that. Whereas when we did it on Desmos and I added the slider there, remember I, go through 0. All right, we came up with -0.4, which is the same as -2/5. But my slider was going up by 0.2 or something, I can't remember. Let's go back to here. Oh, and the calculator. Okay, so you can change that there. We went up to 30 in class yesterday for a reason, but we'll look at that later. All right, so this time, very gradual changes. Okay. All right, so the sliders might help you with your graphing. Okay, in this space here, you might want to actually write the equations. You can do that on your calculator. I've already shown you that. We did that when we did the linear graph. Okay, moving on. Now we've got a log function. Okay, so you might be thinking, oh, I need to make an X. I know that, you know, a basic log graph follows this type of curve. So then, Siri's talking to me. So then you can reflect that. Now, the hard part with a log graph, though, is thinking about, well, what are all the values actually meaning? So that's when you need to say, well, I know a log function has that kind of shape, but I can't remember what it looks like. Just put it on your calculator. So we'll go back here. Let's get rid of all that. That's probably an easier way to clear it. Edit, clear, I don't know, clear all. Whoops, didn't mean to select all, clear all. There we go. All right, so if I wanted to graph that log, so keyboard, remember ln is your natural log, that's just a log of base e. All right, so your basic log graph. There it is. All right, and this should be in your notes, but you can see it's got an x-intercept of 1. So basically, we've got to shift that to the left 1. So when I go x plus 1, graph that again, there it is. Now it's gone through 0, 0. Now I did want to restrict the domains because I only want it to go from 0 to 5. So when I do that, I just get the green section. Now, you're going to face the other issue of, well, I want it to go through this point here, 5, 10. Okay, just like the other ones, I wanted 5, 10. This one I want to be 5, 10 as well. So that means I've got, well, h of x equals some value of a times log x plus 1. Substitute in a point. Now, I haven't substituted in 5, 10 yet, so I'm going to substitute that point in. You can't from memory, can't substitute in 0, 0, so I'm going to do 5, 10. A log 5 plus 1, 10, a log 6. All right, and then just dividing both sides by that log. So that goes, so that's how we get a equals 10 whoops, 6. You can also do that on your calculator. So if you don't know where to go from here maybe, because we're just doing a substitution elsewhere, just do solve on your calculator. Go as far as you can by hand. And then if you're like, oh God, I don't know how to solve this, but I do know how to do it on the calculator, do it on your calculator, okay? That's why you can have your calculator in your SAC. All right, and then the other 4 obviously are reflections. So you can do that later if you want to put those functions in. So you're just going to define it and then just doing h of negative x, negative hx, negative h, negative x. All right, the last one, I've called j of x. I'm running out of letters to use. We've got a sine function, but you'll notice this time I've gone all the way to there. Okay, so my domain, I've gone from -5 to 5. So instead of just taking just this top part and reflecting it, I thought I'd just show you, well, you don't always have to do the reflections. Okay, so for this one, I've just kept it as is. The hard part with this function though is the amplitude is quite easy. So remember, your amplitude is the distance from the midline. So this one hasn't been this graph hasn't been shifted up or down. So your midline is y equals 0, just the axis. So your amplitude is 10. So we're going up to 10. So, okay. I feel like you're pretty confident with amplitude. Now your period is a little bit harder. So remember, your period is equal to 2 pi on n. Now that is for sine graphs and cosine graphs. We haven't covered tan graphs yet, but if you wanted to do tan graphs, just remember that the period is not 2 pi on n for tan graphs. You don't have to do tan graphs in your SAC, but if you do, that's fine. All right, so we've got this graph and you're probably thinking, well, what's the period? Is that 5? Well, your period is 1 full revolution. So if you think about, oh gosh, that was terrible. Your sine graph, there's half. All right, and then we go back up. All right, there's 1 full period. So if I was to extend this axis, all right, so this is 5, whoop, this is 10, this is 15, and this is 20. So basically that section that I've drawn, let's just do it in a different color. I'll do it in yellow, so maybe we won't do it in yellow, let's do it in blue. Oh God, should have probably done it in pink. Let's do it in pink. Let's just get all the, oh gosh, now it's in black. Okay, that section there is a quarter of the period. Okay, so you can get your period by saying, oh, well, if a quarter is 5, then the whole is going to be 20. So that means your period is equal to 20. And then we just solve for n. So we've got 2 pi on n equals 20. So 2 pi on 20 equals n. Therefore, n is equal to pi on 10. And the value of n is your coefficient of x. Okay, so that getting your value of n. So remember, n is not your period. It helps you with your period. Okay, so n is just the coefficient of x. So you might want to do a sine graph. And you could also, to get that, the red sine graph, so this one here. Okay, it is a reflection in the x-axis, or it could be a reflection in the y-axis, or it's also a horizontal shift. Okay, so there's certain, sometimes, well, I shouldn't say sometimes, most of the time, you can get to the same transformation under different translations. Sorry, let me start that again. You can get to the same image of the graph by bunch of different transformations. So this is a good example. You could have reflected it in the y-axis, you could have reflected it in the x-axis, or you could also have done a horizontal shift. So you could have moved it left or right. So if you look at this pink section, that is the same as this part here. So you don't need to really copy this down, but you can see, all right, it's moved across 10. Okay, so you could do, take your sine graph, sorry, I'm just thinking, and you could have shifted it 10 to the left, and you'd get the same if you shifted it 10 to the right. Okay, let's move on. Don't even know how I'm going for time. Okay, so here we've got a cubic. Actually, before I do that, just with your calculator, just if you're doing any graphing, just when you're doing sine graphs or cosine graphs, just make sure you're in radian mode, okay? All right, so moving on to this cubic. So what I'm going to do now is a cubic in expanded form. All right, so there's the equation of a general equation of a cubic. We don't know what A, B, C, or D are, so we've got to find it out. So we say, well, what information do I have on this graph? Okay, so I'm going to highlight them. I know this point here is 0, 0. I know this point here is 1, 7. I know this point here is 5, negative 25. Now, you'll notice you've got two other x-intercepts. They're very, very hard to read. Even that point 0, 0, I probably shouldn't have chosen that because it actually might not be right on 0, 0, but it is. All right, so for the purpose of this graph, we're just going to keep it at 0, 0. But these other 2 points, so let me highlight them because you can't see my arrow, I'm pretty sure. These 2 points here, we can't clearly see what they are. And we can't say, oh, it's roughly x equals 2. I don't care if it's roughly. Don't go building me a bridge and measuring it's roughly 2 meters. All right, I'm not hopping on that bridge. We want to be exact. So I can't exactly see what that x-intercept is, so we don't use it. All right, so let's put our points in. Points on the, I was going to say on the line, on the curve. We've got these 3. Now I've got 4 unknowns, A, B, C, and D, but I've only got 3 bits of information. The good thing is you've just learnt about stationary points. So remember, your stationary points are when your derivative is equal to 0. All right, so your derivative, actually, let's just, okay, so I'm just jumping ahead. Your stationary points are 1, 7 and 5, negative 25. Okay, so you can see they're labeled on the graph. So now we've got 5 bits of information, but we've just got 4 points. So we've got more information than what we need, which is great. All right, this is where you can do things by hand, but also check on your calculator. And you're probably thinking, oh my God, there is so much. I've got to set up 4 equations and then put it all on the calculator. The thing is, if you've defined your function as f of x, and you could even do that, all right, in your exam, if you're short on time, we've already defined y. You can say, all right, f of x is equal to y. All right, so I don't have to write that all again. F of 0 is 0. So you don't have to write ax cubed plus bx squared plus cx plus d. You basically said f of 0 is 0. F of 1 is 7. F of 5 is negative 25. All right, so just substituting in those points. Now your derivative, f dash 1, so when x equals 1, your gradient is 0, and when x is equal to 5, your gradient is equal to 0. These stationary points, the y-coordinate doesn't matter. Okay, we don't need to know what the y-coordinate is when we're solving this function. Sorry, just yeah, thinking, talking and thinking at the same time doesn't always help. Now, there's there's our 5 equations, f of 0, f of 1, blah, blah, blah. On your calculator, I'll just move it over here, you can define, again, so I might clear all that, just because I like a blank screen. Okay, so keyboard, define, and I'm calling it f of x. Now, if you've already had an f of x in there, it will override any f of x, okay? Now, when you're doing a on your calculator, well, when you're doing ax cubed, first of all, put a times in. If you're using 2 letters, okay, so in this case, a is our pronumeral, x is our variable. You've got to have a multiplication sign in there. Even if you had x, y, whatever, put a multiplication sign in there, because your calculator is kind of, if you left it as ax, it's kind of seeing that as together, as opposed to being a times x. Now, just use ABC on your calculator to do A, B, C, and D. I obviously have my computer right in front of me, so I'm just going to use the keyboard. Plus B times, don't forget the multiplication sign, plus C times X plus D. Now, whenever you put something in the calculator, just double check that it's in correctly. All right, so I've defined it. Awesome. Now, if we're solving for A, B, C, and D, now we know D is going to be 0 because D is just your y-intercept, but we're going to just assume we don't know what it is. Okay, so we're solving, and this is quite a long one. If you were to do this by hand, this will take you forever. So just set up your equations and then use your calculator. All right, so we need 4 equations. You don't need to put all 5 in. So we press this button above 10. I don't know whether you can see it's highlighting in blue. You need to press it 3 times. So it'll come up with 2 equations, 2 spots for your 2 equations, and then you need to put a 3rd and a 4th in. Now, because we've defined it, I don't need to type in the whole thing again. I can just say, all right, let's do f of 0 equals 0. F of 1 equals 7. F of 5 equals negative 25. And then we'll just do the first derivative. Now, when you're doing your derivative, just go to interactive, calculation, diff, and we're doing the derivative at a value. Okay, we're doing it at x equals 1, so the value is 1, and your expression is just f of x, so we don't have to type in the whole thing. You're going to come up with an error sign, just ignore that. All right, because we're just going to say, all right, I don't know why it comes up, but it doesn't matter, equals 0. All right, and then on the other side of that vertical line, we're solving for A, B, C, D. All right, so I'll just give you a second to make sure you've consumed all that. Rewind if you want. Didn't get those steps. All right, and then press N. Oh, gosh. It is so annoying when that happens. Oh, I put in full stops instead of commas. There we go. All right. There's so much pressure when you do something quite complicated and then you go to press enter and you just do a little prayer and hope that it works. Okay, so that was an easy fix because I put full stops instead of commas. All right, so we've got A equals 1, B equals negative 9, C equals 15, D equals 0. Okay, so if you wanted a cubic shaped graph and you wanted certain turning points, just do what I just did to get the equation. All right, you can graph it on your calculator and put in different sliders if you like, but just sketching it, that's all I did with this example. Actually, I did choose 2 turning points that work quite nicely, but you can see they didn't work nicely with my x-intercepts. So, you know, can't have everything. But what am I saying? I chose those points because they worked out nicely, but you can choose whatever turning points you want. All right. Yeah, so the reason I chose them, they're nice there, but also on the calculator. Where's my calculator? I got integer values for A, B, C, and D. You don't have to do that on your SAC. Okay, so I did that on purpose because, you know, sometimes when you're showing people stuff, it's nicer to have integers as opposed to fractions or something. All right, now your next graph, you can see it's the same shape, it's just been shifted down. So it's shifted down 7. So your value of d is now changed to -7. You think your y-intercept was at 0, now it's at -7, so d is -7. On your calculator, now I tried this the other day, I might just see if it works this time. So, actually, I think I figured it out at the end of the lesson. If we go to define and we did f of x, now remember we defined f of x with just using a, b, c or d. This time I'm going to say, all right, define f of x given that, oh actually, no. Now just bear with me because I did this, I'm pretty sure when I was, oh yeah, didn't do that. No, I don't want that either. I don't know why it does that. I don't want to, it's giving me a parabola. I don't want a parabola. So I found the derivative. Okay. Let's just do one last thing. No, I don't want solve. All right, I'm going to try define. I might do define g of x equals, no, that's not going to work either. All right, I did do it the other day and I can't remember how I got it to substitute the values back in, but it hasn't substituted them back in. I don't know what it's done, how we got that. Anyway, so now we know what A, B, C, and D are. All right, you can just substitute them in to get the equation of that line. So let's just maybe do that. So f of x is equal to, so a was 1, so it's just x cubed minus 9x squared plus 15x. And then it was plus 0. Okay, so that's the equation of that cubic. This one here, it's just been shifted down 7. So it's going to be I should probably use f of x. Let's choose g of x. Well, basically, g of x is equal to f of x minus 7. Okay, so it's going to be x cubed minus 9x squared plus 15x minus 7. Now, if you didn't understand what was happening there, or you wanted to do it on your calculator, you could just use a slider. So let's go back to the calculator, go back to, I might actually define that because I'm going to do a few things with it. So let's define f of x equals, now I'm going to put in the values of a. So x cubed minus 9x squared plus 15x. And then we had plus 0, so we don't need that. Okay. Now on my calculator screen, sorry, my graphing screen, I'm going to do f of x again. But this time I'm going to add in a slider. So plus d is going to be my my vertical translation. So I'm going to tick that. All right, so you can see I've added in a slider. Now, remember before I changed the settings to 0.1, I don't really want that. I want it to be back at 1. And I'm going to go back as high as 30, and I'll show you in a second. So let's say, and this is a good example of how to do, rewind. There are questions on past exam 2s with the multiple choice that will ask you to say, well, currently there are 3 x-intercepts. Maybe you only want 1. So you're not sure, well, what do I do? Well, you've got to obviously shift the graph down. So what does that value of d have to be? So you can see when it's -7, it's on the x-axis. So anything less than -7 will only give you the 1 x-intercept. Now, if we wanted to go the other way, So if we kept moving the graph up, and there it is, 25. All right, so now we have one x-intercept, or what we do have two, but one is sitting on the graph. So anything greater than 25 will only give you one x-intercept. So in this spot here, oh, no, didn't want to do that. Oh gosh, corrupted. Sounds dodgy, doesn't it? Sometimes, oh, can I save you before you scare me like that? Okay, so basically what I just did on the calculator is this point down here, 5, negative 25. I've shifted it up 25. So any point has shifted, every point has shifted up 25, but only the y coordinate. So this one here is going to be shifted up 25. So it's going to be 7 plus 25, 32. And then this one here is going from 0, 0 up to 0, 25. Okay, so if I graph that, show you on the graph, and you can't really see it. God, I wish I could, it was easier to zoom. All right, it's not really working for me. Okay, so if you played around with the zoom, you will see those points there. So you can sketch that graph here. Okay, so we went, that 0, 0 point went up to 0, 25. Just make sure your scale's right. So it's up here. Right, so it's going up by 5 each time. Your first turning point was at 132. So 32 is going to be around here. And then our other turning point is at 5, 0. All right, so basically we're going up, down, whoops, very wonky, and going back up again. Now with those three graphs, they're the same shape. Oh, I didn't stop. I kept going with my graph. I probably should have stopped. It's the same shape. Okay, so when you have a graph that's the same shape, your gradient function is also going to be the same. So that's what we're going to do down here, just to show you that the gradient function of both of these is the same. So if I go back to my calculator, all right, so there's our cubic. All right, I might just put it down again so we can see those turning points. All right, let's maybe do, okay, so there's the first one we did with d equals 0. All right, on here, you can also do your derivative function. So with your keyboard, you can just go to, all right, so we want to do d dx of f of x. And I'm just going to graph that without the slider in. So there's your gradient function. Right? If I change that value of d, so at the moment it was 0, now let's change it to -7. Graph it again. You can see your gradient function, your derivative function does not change. If I change that to +25, all right, it also doesn't change. So the point I wanted to make with that is just to show you that your gradient is dependent on what is actually happening in your graph. So if we have a look at this one here, we're increasing here. And for the next one, we're increasing here. Same with this one, we're increasing here, increasing here. And if I go back up to the top, increasing here, increasing here. Now, if we're looking at decreasing, let's do that in blue. So it's decreasing here, decreasing here, decreasing here. And your stationary points are at the same, I'll do it in pink, are at the same x coordinate. So at x equals 1, x equals 5, x equals 1, x equals 5. So when you're sketching it, obviously you can have a look at the function on here, and you can get your turning points of that derivative as well. Let's just turn that off. Okay, so if you wanted to know what the minimum point is, so let's just do function minimum, you can see it's going to come up with 3, -12. So that might help you with your sketching, because what we've done before is we said, okay, I've got a stationary point at x equals 1, so that's going to cross the x-axis at x equals 1, and we've got another stationary point at 5, so it's going to cross there. I know it's increasing from 0 to 5. Well, it's probably more, but I'm going to do the whole part. So let's just pretend it was going down like that, and then it's coming back up here, and then it's decreasing in that blue part. Now, instead of just drawing it willy-nilly, you can say, oh, I know that that turning point is 3, -12. So halfway between 1 and 3 is, halfway between 1 and 5 is 3, and then it's going to be at 12. So you could do that by substitution as well. All right, but there's that part in the middle. So it's still below your x-axis, because remember, we're sketching the derivative function, f dash x against x, not f of x against x, but your derivative. Okay, so that blue section is in the negative derivative part, where your gradient function is negative, and anything above is positive gradient. All right, this other, this one here was to sketch the same thing, okay, but you can obviously do that as well. I think that was all I wanted to show you. Maybe just one last thing. If you wanted to do tangents or normals, and we've done this before in class, but I just wanted to quickly show you, you can do them on your calculator. So calculation line, you can do your tangent, or your normal. So again, you can just type in f of x, and at what point, I don't know, let's do 3. All right, and it'll come up with the equation of the tangent. You can do the same with the normal. Just be familiar with what your calculator can do. So you can also get the minimum and the maximum of your function. So I know for f of x, our minimum is, so we did this one here, our minimum is, it's going to keep going because I restricted the domain here. So on here we're doing f of x, and instead of doing from -infinity, otherwise obviously your minimum is going to be -infinity. Let's just do it from x equals 0 to x equals 10. All right, and then you can see there. So your minimum value is -25 when x is equal to 5. All right, you can do that for your maximum as well. I'm just trying to think if there's anything else that might be good to know on your calculator. Obviously solving, and yeah, probably don't really need any of that. All right, so I'm going to leave it there, girls. All right, that's pretty much what we covered in class as well. But use your calculator to your advantage. Okay, bye-bye.